again, microphone on, quick live, copy URL, go to the quick hour or last stream refactoring. I need to get a more generic thumbnail, just blah 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 blah. All right, get this off my screen. Save my description. Okay, so where the fuck did I leave off? So I'm in resolve types. Okay, so declared type is .node. Declared type here is a struct type. We want it to be unqualified by default. Then node, not noder, noder. All right, expected type needs to be type, and don't think that has a declaration anywhere. It does not, so that's fine. Then everything in that function, a type pointer for analyze type, that's fine. Reference to type node, that's fine. Expected type, that's fine. Node, if expected type's node is not null, expect the expected type node state to be some okay. Then if node state, yep, that's the early out. Okay, move on. Lots more types. Type is no return, no decal function body type. So this is where I would love. I have a second pass at the refactor that I want to do, which is all of these names need to change. So I will to do that and probably leave a to do on everywhere that it's used. Maybe? No, because everywhere that it's used will get compiler assisted refactored later. Okay. To do Laye type. Hello, Zed. I'll go. Type functions should take the qualified type for convenience. And the original functions should become a node type. Take a node as the core implementation. Or just remove them entirely. Probably. There's my notes. So body type. So I like in this case, I don't really want to go through the entire compiler just to turn this into type.node, only for me to go back later and undo it. I'm pretty good. I'm about to go to lunch, but before then I wanted to be a little productive, and I figured, hey, if I'm on camera, I have to be productive, or at least be chatting, and chatting is fun. So what I'm doing here is I'm refactoring the compiler to have a qualified type wrapper around it. Boop-a-da-doop-doop. Email. So I'm going through the entire compiler. I've gone through the parser already and made all of the necessary changes. I can't test it yet because I'm still going through SEMA. So we're going through SEMA. Once we're through SEMA, there should be a little bit left in IRGen for converting types. And once we're done converting types, I think we can test again. So what I'm thinking here and what this note is saying is that this interface should just take a type. And since these are simple functions, I don't think I'm going to even... don't think I'm even going to create a second wrapper around. If it's Laye type, it should deal with the Laye type. Type. So if I go into size in bits and we start here, then we can say like assert first of all, node pointer 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 12, 13, 14, 15, 16, 19, 20, 6, type. Okay, so then we have to go do all of these. So size in bytes did not get an update. That's fun. So type node, node is type, type node. Then we pass in type, but since it's going directly to size in bits, we don't need any of this. So then we have Laye context, not Laye context, Laye node, type node is type node probably. I can just replace the instances of type with type node. I guess I could also just re-index it every time. But yeah, fuck it. Let me come over here. Type node. Not underscore. We removed the underscore. We're just going to do this. So Laye type, bonk, 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 bonk. Okay. Type a line in bytes. Type referenced type. Oh, because it's in bytes. The in bytes ones, for some reason, have not been updated. Bits, size in bytes. It's right there. No, that's fine. A line in bytes. Type, Laye type. Argument of type Laye node is incompatible with time of the parameter of type Laye type. So referenced type. Oh, because it's a named reference. It's referencing the type. And the reference type of a name ref is always unqualified. So I need the unqualified thing to qualify the type. I don't think I can do this outside of Sema. And that's in Laye.h. Okay, to the very bottom. That's fine. So lty just qualifies the type with no qualifiers. So I can pass it to these kinds of functions. So then type is poison. We have a huge pattern of things that we can change here. And I think it's the same for all of them except for these two. So we can just say type node, and then type node. Copy all of that. And everywhere that we see this, becomes that. So then all I have to do is here, no. And that should cover all of those cases. There we go. So then we've got a few more things to fix here. Type is no return type. Type size in bytes of query is expression size of query. If it's a type, then we want the qualified type of query. If it's not, we want the type on its own. Down here, type is name ref from A. Type is probably easiest to do. Type is alias A type. Type is alias B type. And assert that it's not an alias here as well. Get on my desk, okay. Then type, did that not happen? I thought that happened. Type, and hopefully finally, Laye type array rank should take Laye type array type node. I can spell node correctly. Type array rank. Then Laye type print to string while we're here also needs to be updated because we want qualifiers. That is the screenshot button. Type. I got rid of a lot of semi-errors, it looks like, so that's good. Type node, like everything else. Type node kind. Then if type node primitive, let's just grab the type plus the arrow again. Just starts up here. Bonk, 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 a bonk, a bonk, 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 a bonk, 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 node. Okay, so then somewhere in here we have to get the is modifiable part. Type node, type error pair, error value type node, which is not ideal, actually. This is wrong, but I don't have any types right now that care about it, so it's fine. So then, what's up here? If node declared type, this is in debug, okay, that's fine. Node is not equal to null. Let me print that. Okay, so then in here, template argument. Laye type print to string, template argument. If node is type, template argument. Okay, but the template argument could be qualified, so I have to go update that. So template arguments. Wait a second. Problem. Template arguments could still be values. So if I want a qualified type in here, I need a new type for my template arguments. This refactor is getting bigger than I want it. So we have Laye type def struct, Laye template argument. And just call it arg, because we know what an arg is. Fat fucking fingers, fat, god damn it. Laye node, Laye type, and bool is type. That's probably all I need. I can put type first, so it looks like it's a type or a node. So then template argument goes into template arg. Oh, that's just in name ref right here. That's right. Template arg, template arguments. And then I can go back into debug. We're not using template arguments anywhere, so like there's not much to update. So let's find template arg. Assert template argument does not, that doesn't make any sense anymore. So if it's a type, template argument is type. Template argument type, else node. Else if template argument node kind is evaluated constant. Otherwise it has no fucking clue what it is, and that's fine. Woo! Next, type node kind, unimplemented type kind, type node kind. Then, template arguments again. Template arg. If template argument is type, template argument type with color, node, okay. Then type function, type node. So really, everywhere that I've got this is modifiable check just needs to go at the absolutely end right here. But what is this referring to? If type node is modifiable, we append the modifiable nature of the type after the return type, which is just wrong. So that doesn't even need to go there. That's all fine. This is all fine. So then if type is modifiable, we append mute to the end, and that's it. Cool. So debug is done. Data type is array type dot node. Array type. No, that is correct. Array type. And then array type node. Okay. So then data is good. Okay. Now we should be able to go back to sema. New error is at the top here. So assert type is function, declared type. Yes. See, I was afraid I was going to have to go undo all of that. Up. For anybody unsure what I'm meaning by a qualified type here, I needed to separate the idea of the syntax of a type from its ability to be qualified with modifiers. Yellow. So previously this is modifiable, meaning the mute keyword, mutability of a type, was in the type node itself. But then I couldn't have, like, for example, foo mute, where foo referred to a struct type, without changing the underlying struct type. Because this would become like the equivalent of struct foo. We'd replace the word, and we'd still need to have separate type qualifiers. So refactoring the entire compiler to use this type instead. So I can do that. And we are about halfway done, I think, aside from testing and debugging. So decl struct assert that the declared type, this is all just assertions. These assertions are going to be the death of me. I should really get better assertions, but I've got like 1,000 asserts in my code base. So it's a little, another refactor for another time. Okay, at this point, it would be a void type. Laye type is void. Should actually continue to use that. I don't know why I changed that. Then, iterable type is now of type. Assert node. You can assume whatever the hell you want about me. I don't care. I've got facial hair, a dick, and a low voice. But I like to be cute sometimes. And I like pink. Pink is my favorite color. Wish I had long flowing pink hair, but I don't. I'd love to look good in a skirt, but I don't think I do. Imagine me however you want. And you don't have to imagine either. I've been on camera before. You can check my older videos with a face cam. Iterable type node kind. If it's an array, and really, I should just be saying Laye type is array, iterable type. That's the whole point of these functions in the first place. For each index binding, blah, 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 blah. Then that's an error, k. So element reference type should be a type. Dude, pink is fantastic. My keyboard is pink, my bed is pink, half the books on my shelf are pink, my bathroom is covered in pink. Obviously, my profile picture is 3 different kinds of pink. My phone case used to be pink. Nah, I made that. I did make that myself. Dude, it'd be cool if I looked like that. I don't. It would cost way too much money to look like that. L-type. Ooh. Never assume online. Anime girl profile picture, 99%. It's a guy behind it. It's just how it works. Okay, element reference node. I really probably should wrap this in a reference after the fact instead of before the fact, but it's a simple Leah anyway, so it's fine. No offense taken. Node for each element binding declared type element reference. Okay, so oh, I should probably make this bigger for you guys. That is the zoom everything button. I keep doing that. Everybody has anime profile pictures. It's the way the internet works. Okay, so that should still be fine. Element reference type becomes a type reference. We're referencing. Okay. There's a half-decent reason why anime profile pictures, especially nowadays, like the reason like 20 years ago was because of that's just the culture of the people on the internet, basically. But now, like, so many people want profile pictures that aren't a picture of their face. And like, you're just going to go to popular media. You're going to look up stuff. You're not an artist. What are you going to do? You're going to go find some character that you like, and it's not going to be a character from a book. There's no pictures in that goddamn book. So it could be a movie star, but you're like, damn, that's a real fucking person. I'm going to be impersonating a movie star. You know who's not real? Cartoons. It just kind of makes sense. It's the natural order of things. You're going to go find a not real person to be your profile picture because nobody will assume that it's you. You're not going to be, you know, oh, you're Benedict Cumberbatch? No, I'm not. I'm fucking Goku. It just works. Type node type. The Laye node is type needs that, but that, if we're in, like, it shouldn't, like, it's an assertion for a reason, but I shouldn't have to assert that. Type is function is fine. Expected return type is now type node. Node is type node. Again, if it's in a type at this point, I shouldn't have to assert this, but I will. If return value is not whatever, type is no return, whatever. Okay, so I'm still this function return type. That's wrong. That's wrong. Yeah, I'm at like 12 or 13,000 clock. So I want to do include and source and lib. That's the wrong. I'm in my documents. Why am I in my documents? Clock source include lib. 12,000. 12,000 lines. By file. Ta-da! Screenshot if you need, ask me anything, I don't know. Parser being the biggest one is still the surprise to me. Sema's not complete by any means, it's probably going to get twice as big, but the parser is significantly bigger than Sema and IR generation at this point. Parsing my shitty-ass syntax is taking a toll on it. I guess almost 1,000 lines coming from knob means we're down only to 11,000. I didn't write knob. Knob is the one thing that we depend on just for a build system. The only dependency of the Laye compiler, technically, but it's not really a dependency. Parsers are complicated the way that I'm writing them, but also, like, the biggest complication is the way that I do for loops. I'm not going to do that. We're going to go to for Laye. Right. So this is a valid for loop. Starts with the keyword for and an open parentheses. This is a valid for loop. It's the same thing, but it's missing the whatever. That's the easy case. The condition's gone. Same thing, missing the end, but that's easy to check. It's just another if statement to check on it. This one, we're missing the declarator. That actually makes it very easy to parse, but again, it's another if statement. You know, regular C-style for loop. We get up here, though, now for is actually a while loop. So we have to check. We have to be able to parse either a declaration or a statement or an expression in the first place, which I think C technically has to do at this point anyway, but it always knows when it sees for that there's going to be a semicolon here. So like it can kind of it gets away with it pretty fine. But I have to be a little bit more careful there. But then also, right, like everything's omitted or nothing's there. And that's just the stuff I've implemented. That's not even saying for, like, I don't know, foo in bar. Or I think colon was my syntax. I forget exactly what. Where foo then, like, now we've got iterable syntax here, right? Like this kind of stuff where I've made things harder on myself, and the parser is just branch upon branch of what is the specific case that's going on here. Types also a problem because types are C style. They start at the beginning of the declaration, but a name can be a type, and since types are recursive, this is a type. So it's not that's type. That's a type. And we have no idea if we're in an expression until this type fails to parse. So I have to do a whole bunch of conditional logic on types to see if we've hit a type, and if we haven't, then it's like an expression, and like just a bunch of conditional logic, and it's all in C. And I'm throwing a fuck ton of asserts in there. I want to see a clock utility tell me how many asserts there are. Because if I come in here and say assert, not this file, that file's fine, that file's fine, that file's fine. I've got 1,500 results in 18 files. Some of these are knobs, so knob doesn't count. There's all the assertions just in context. Here's all the assertions in my IR. Lots of asserts. I assert entirely too many things. I'm an assert programmer. Okay, actually, Sema. Back into Sema. IR is doing a couple of things. What's wrong in the IR? Curious. Type destroy. Types I. That should be node type destroy, probably. First off, what the fuck? Second off, where are we calling this otherwise? Oh, no, that makes sense. That makes sense. Laye type destroy. Laye type type. Parameter types. Oh, hold on. Oh. Changing these two was wrong as fuck. Don't know why I did that. Somewhere in here took me to the wrong thing, I think. So this return type should be a whatever, and it took me here, but I wanted it to take me here. So Laye type return type, that makes sense. Parameter declaration, that's fine. So Sema current function declared type node. That's where the problem is. Boom. Okay. Okay. Then expected type. If the expected type has a node, converter error. Like really, this kind of stuff, I need to clean up how that works as well. Okay. So assert that there is a type. Assert that there is a type. We've done all of our conversions. So this returns us a type. Convert to that type. Cool. Node type is modifiable is just dot is modifiable. So I could probably make that a global substitution. If I come back here and just say that turns into that, that will cover some cases and most likely be right. And this type is poison. Why don't you use those fancy LL, LR, LALR, probably LL as well, parsers? I forgot every other type, but it's supposed to. They do not make your life easier at all. They are going to make your life hell, and I would not recommend using them in a real project. They not good. 99% of the time, you want to roll your own parser. Use a parser generator for something really simple, maybe, like a quick configuration file that doesn't already have a parser. That might be fine. Probably not a good use for it still, but like, I don't know. You're going to get shitty error messages. You're going to get shitty performance. You have to learn the parser generator system. You've got to tie it into your custom implementation of your data types and stuff. It's just not worth it. Callie type is type. Assert that the types semi-state node array count of parameter types. Okay. Return type node not equal to no. Okay. Then that's good. Nothing here looks wrong. Okay, so node index node ref. Okay. So type kind is typing. So this is where I should definitely again be using my handy dandy functions that I'm not using. Laye type is int, just arbitrary int, because I should really have just made my types, my node opaque from the start. More verbose code, but I'd be actually using the correct fucking functions. So then if it's assigned, which again, I have a thing for, is signed int right there. Else it's an unsigned int. Else must be of some kind of integer. Cool. Then value type of the value that we're indexing. Value type 0 node like that. So array count value type container. Okay, cool. That's good. And then assert node type node. All right, member type value type node. In university, I had an opportunity to work with Bison and Flex for a college project. That was a great experience, but yeah, better have your own parser lexer. Yeah, they're not like, they're all theory and education and not bad, but not good for a production language, right? You're not going to build a general purpose language you want to distribute to a bunch of people and use a parser generator. You just don't have enough control over what's going on. The experience for the end user is not going to be great. And really, the whole reason to use your compiler is because it's got the back end half. You got to have optimizations, you got to have your UI, good error messages and stuff, and none of that has anything to do with the front end. And the front end isn't going to give you those good error messages if you use a parser generator. I don't know if I phrased that entirely correctly, but I think my point still stands. The user interface is the part that I was referring to. The rest of the stuff I don't care about, whatever. You need good error messages, and you're not going to get that with a generator. Without a lot of fucking work, at least. Declared type needs to exist. So name refs are the whole reason we're doing this. I might have some refactoring to do when we get to name refs for types. Referencing a declaration won't change. So here we're referencing a declaration. We've decided that a name ref can reference these things, but not anything else. So I'll say, hey, bad. If it's a binding, it's an L value. We're not assigning to function, so a function is never an L value. Structs cannot be used as a value. I wanted a special error for some of these types. These are unknown. So we'll do other types here as well. That's fine. When we get to a name ref in types, a type name ref, that's where the things are going to change. I missed an error up here. Assert node. I think I was reading a comment. Reading a chat. Okay. So binary and, or unary and, probably. No, this is, yeah, unary and type is pointer. So, yeah. So Laye type is pointer. Again, another function I should be using. Then if node type node container element type is node unary operator. Okay, cool. Type is modifiable as true. By default, I think so, yes. It should be... See, that's actually a problem, because we're copying this. So this actually shouldn't be the case at all. That's a case where we were modifying the underlying type when we should not have been. So in this case, if we have like int a equals 10, then we had a reference to a, it was going to modify the mutability of the type a to be int mute, because it was a pointer and it was navigating through to this part of the syntax. So now what we've got is int is the node, mute is associated with it. So I guess I should still have it, but since it's at the fucking, well, no, because now we know. We want ref a to have the same mutability as the underlying type, right? It's a reference to this thing. So I don't think anything has to change. And in this case, it's referring to the parser already constructing something. In the case of that int a, we already knew the type of a was int, because like we don't have to semantically look that up. It's visible from the syntax that it's type int. So it's going to pre-generate type int for a, and the parser, anytime it can, is going to also pre-generate the types for reference to things. So this would be a reference to, or a pointer to, int. A pointer in this case, a pointer to int. In other cases, it's not going to know, but that will be resolved by the semantic analysis pass beforehand. Which it should be doing, I think, here anyway. This might be... I might need to test this with more complex types. It might not be handling them correctly now, but we'll get there when we get there. Pretty sure I've got a piece of hair in my mouth, and I don't like that. Okay. Value type no ref, the type. Assert that the node, not null. Hey, look, type is pointer. We're using it for once. Thank God. Convert to the type. Else I did that already. That's good. Then pointer type. It's value type no ref. If pointer type, type container, element type, kind is node. Okay, so then here we want to say type is void. Laye type is void. Pointer type, node, container, element type. Or it's no return, I assume. Yeah. Type is no return. Then node type is pointer type, type, element type. Okay. That's dot node, element type. Set is L value, great. And then cannot dereference, that all looks fine, cool. Binary types. For binary operators, not types. So left-hand side type, right-hand side type. Assert that the type exists. This is not the greatest check. I don't need to do this everywhere, but I've done it and I'm sticking to it. I can be even more and go back to my Laye type node is type. I could do that too. Not right now. So type is int. We did it. Assert node type find. Cool. Common arith types. Fine. All right. Type node. Type node. If it's an int, a bool, or whatever. Okay, so then here, if type node, and then this, and then this. Okay, that looks fine. Literal bool. Yeah, again, so in this case, we know what a bool is. We should have populated this at parse time. If expected type, if there is an expected type, it will attempt to convert the bool literal to that type. Exactly the same thing here. Come on, editor, you can do it. And here, then, okay, so then here we have a type name ref. This is what caused me to start this refactor in the first place. So we're going to go through this a bit better. So a name ref has to refer to a declaration. In this case, we want the type declaration of something. So reference type, lookup declaration, cool. This will do our lookup. At this point, we should have some node looked up, because if we don't, it will have broken from here. It needs to be a declaration. We're going to reference that declaration here. And I believe, yeah. So every single name ref always will reference some declaration. Any name ref that is also a type will reference the type that that declaration declares. Reference decl node declared type does not equal to node. Okay, so this says whatever declaration we got must have declared a type. I use the declared type for all kinds of declarations. That is, like, int foo has a declared type of int, but struct foo has the declared type of struct foo, the type that it declares. Because they're never going to overlap, and they're very similar in meaning if I call them declared type, We use the same thing for both. So in this case, we're referencing a type declaration. It has a declared type of the type that it declares. So then our type is going to become the declared type. Now, since it is a declared type of a declaration, it will not have any qualifiers on it. So we'll just copy it in. It'll be completely unqualified. Something I'll have to do then is say node type dot is modifiable. So here's the thing, right? We're already in a type name ref. We need to then grab. Okay, fuck. I may have to change this a touch, and I'm not entirely sure. Because we want whatever we're referencing here to inherit this type. Okay, so maybe we don't do this here. Maybe, let me back up for a second. We have a Laye sema analyze type. Maybe after we've analyzed a node, which is here, we can do the replacement of the type with whatever it references. That might be the place to do it. So if I said if, do I have type is name? Type is name ref, type this. If it's a name ref, then we want to assert that type node type name ref. No, it's just name ref dot reference type is not equal to null. And this does not have the qualified wrappers around it because we know it came from a declaration which can't be qualified. So then what we want to do is turn this type into whatever. So type, you'll see in just a second. Laye type. We're going to say dot node is this. That's step one. We now know the type node is this. Dot is modifiable is type is modifiable. Whatever came along with the name ref. But then source is going to be type. Whatever node the name ref is. It isn't, okay, it does like that. Boom. So that should transform our name ref type into the underlying type with an implicit reference back up to whatever name looked it up in the first place. So then the rest of the semantic analysis pass doesn't have to care if there's a name ref anywhere. It will be resolved to its underlying type. The same will probably be true of a regular alias. In an alias, a type alias is going to have the underlying type. So our node will become the underlying type. And the underlying type of an alias could also be qualified. So we want to reapply type qualifiers. So let's say the easiest way to do this is, I think I have a function for this, type requalify or add qualifiers, or type, hold on, so somewhere in here, type add qualifiers, type with source. So I'm going to say type with source, which is going to be the new type node, the underlying type. The source type is type node, and type is modifiable. Would be type is modifiable, or just do a regular or, I guess, with the underlying type modifiability. Just apply the union of those two. Underlying type is modifiable. So then this becomes this. Underlying type dot node. So I can replace this with Laye type underlying is this. Okay. So then everywhere that we have this underlying type, make it easier. I don't have a function to take this underlying type and add a second type on top of it, so I'm just manually doing it right now. That's what we want right there. So underlying type dot node. Have the source be the current type that's an input, and apply modifiability here. So for example, if we had alias, my internet's so crappy I'm constantly getting 1440p, I can't see anything you're doing. Well, I can only zoom in so far. I can go one step farther and see if that helps you, but beyond that, I don't think you're gonna see anything. So if we have an alias, foo equals int. The type of foo is just int, with no modifiers whatsoever, no mute after it. But we should probably still be able to say foo mute bar equals something, right? So what this will do is it'll set the alias foo as the underlying type, and it'll apply the modifier mute to int, or rather, I'm using the terminology wrong. The source type from this will be the declaring type foo. The source type. The underlying type is int. We're going to apply our new modifier mute to the underlying type of int. And I think that makes sense. So that handles those two cases. Strict aliases don't get changed, so that's fine. Okay. We will want to do some unwrapping of strict aliases, like probably binary operators for strict aliasing to an int, maybe. I don't know. Equality at the very least. I don't know. I'll have to figure out the semantics of what does and doesn't come with a strict alias. Then I'll go back. All right, so type function. We're analyzing a function. I think we've done everything we need to for nameref, because nameref gives us a... we still need the referenced type. So node type. This should say node... The node type shouldn't change. Node nameref referenced type. Nameref referenced type. That's what should change. Because we don't want to change the type. The type is type. The type of the type is type. But the type that it references, that's what needs to change. So the reference type here is a node. And we want the declared type dot node. So then we can reference a struct, enum, or alias just fine. We cannot reference a binding or a function. In any other case, we haven't decided yet. Okay, so then we've got type function. Start that has a return type. Analyze the return type. Make it poison if it fails. For everything in here, analyze it, make it poison if it fails. For the array type apparently is good. Beautiful. Okay, assert that it has a type, but it's not invalid or unknown. Always resolve it to poison or a valid type. Okay, then semi-discard. Here we need to be using Laye type is void. Again, or type is no return. Yield, this is the benefit of having functions to wrap things like this. No return. I wouldn't have had to change this otherwise. Then conversion. Oh boy, conversion's going to be big. From type here. From type needs to be a type. To type should also be a type. I think I did that in the declaration. Declare, 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 declare. Static int. Well, probably not in the implementation. I did it in other places, but not this one. Assert to node. Okay. From node. And then here I should be using the wrappers. Laye type is poison from. And the Laye type is poison. Like that. Then if either of them have errored, then we assert at this point they should be okay. Then L value to R value conversion, blah, 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 blah. If from type container element, okay, type equals node. This is fine. Cool. This will have to happen soon. Then if it's a pointer, we do the same kind of check. We want to check the elements. Then pointer to a pointer, pointer and a reference, that's fine. To, that's all fine. I probably can find a way to consolidate those, but it's C, so I don't have like fancy closures. Okay, apparently that's it. Then here we just need these checks, but we really don't need these checks because they're going to happen here anyway. I need it before node, semi-state. So really all I have to do is these two. I'm going to simplify some of these because this call to impl is going to do the rest of our asserts for us. So same thing here. I need to know that node is good. I think, no, I don't, because we're going straight to a call to semi-convert. So it's going to handle that for us as well. Convert to cvar args. So the FFI int type is going to need to be, we'll assert that the type node is not null, that's fine. So we'll just lty convert it to an unqualified but qualified version of the type. So then FFI int type node will be node type primitive is signed. So at this point we know it's an int. So really this should just become Laye type is signed int. Like that. And then the bit width would be the size of the int bit width here. And then we return. Otherwise, we're going to start reporting some errors or whatever. If it's pointer size, it's fine. Anything less than the size of int gets upcasted to int. All of this looks fine, I think. So then A type node and B type node. Try convert both ways. I don't like this function here because it's going to try to convert and then try to convert again. And technically try convert doesn't have the ability to unwind. Because it's just going to call the impl with false, and false is perform conversion. Oh, no, that's fine. That's fine, actually. No, I think I did that correctly. So long as I obey this false, then I think we're fine. Okay, so then to and whatnot. None of this needs to exist. It's just making a call to impl. I think the same thing here. These are just going straight. We only need to assert that A and B are fine. And the rest will be handled by the try convert or the convert. Then, about 10, 15 minutes before I go, by the way. If you want to chat anything else up, I'll stop the talk. Otherwise, I gotta go get ready for lunch, and maybe I will stream afterward. Either we'll continue this refactor, or I'll get back on Hibiku. I have not dropped Hibiku. I've been doing a little bit of book writing, a little bit of restyling on the website, and trying to figure out how I want to write things. I wrote another draft for another page, but I don't want to work on the compiler itself off stream, so I just haven't had the time to go back to the Hibiku parser. But maybe we do that later. Maybe I go play Helldivers. Helldivers just came out, and we're enjoying it a lot. So I don't know. Type. Wrap with cast needs to know about the type. Type node is not null. Make sure it's a type. Cast node wraps the type. That's good. Pointer to integer cast, same thing. Type node null. Probably have the same other casts, but that's fine. Node 2, node hello type node 2. Wrap with cast. So if we're just calling wrap with cast is already doing all of these asserts. So the only thing I need to assert here is that node does not exist, or is not null. And here we're doing nothing. That's an implicit cast. That's fine. Then L value to R value cast, I think, is doing everything correctly, except for this. This needs to be type node element type. Type as reference is being used correctly. That's good. Implicit dereference needs to know about the type, so that's fine. This is using the correct function, so that's fine. While it's a pointer, whether it's type, underlying type, that's great that we still have a type. Return true if it's an L value. Okay, implicit dereference here. Same kind of deal. We do want to know that both of these exist, but this one needs to be using Laye type is reference, which it's not. The previous one did, this one did not. Wrap with cast, node type, type container, reference to L value. I think that's fine. Leave that there just in case I do need it. Get pointer to type. So the element type needs to exist, needs to have a module. The node needs to be a type. The new type, we're going to create element type node, element type node location. Okay, and then return. This time we will qualify it at the very end. Type. Okay, do some of the very same stuff here. Node and LTI. And node. Node LTI. Okay, so that. Oh, this needs to be changed. And there's one new error all the way at the top here, probably from our forward declarations that I missed. Cool. Technically, that is all of Sema done. Still can't test it until we get through ARGen, which shouldn't have as many, right? We've got some up here for type conversions, and we've got some down here for manually handling types and things like casts. But IRGen will be much easier. I think I'm going to call it there, though, not start an IRGen. I said 10 to 15 more minutes, but I got through with Sema faster than I thought because we were already at the end. So I'm just going to call it there. Thanks, everybody, for stopping by. If you have any last-minute questions, I'll wait for a second. Otherwise, I'm going to go eat some fried chicken with my friends and try not to feel fat. Hey, good. Let's... get the type refactor. Just so I have something to fall back to, which probably includes Laye, so I need to do include, and I'll just use the same commit message because I forgot it and I don't want to amend it. It's fine. All right, well, thanks for watching. I am going to go and see you guys later. Have a good time. If you have not, actually, I should say this first, join the Discord where we talk about stuff and call each other assholes, apparently. Because we had a little oopsie, and I'm sorry, I got a little bit angry. Anyway, call each other out. We're, am I the asshole here, or whatever the fuck I was. Anyway, come talk about development stuff. Come follow the development of my book when I get to that. It's been a week since I've talked about the book. I'm going to do that, I swear. Yeah, get notifications when I go live. Maybe you'll see me go live learning how to use GIMP so I can make a new thumbnail. I'm stupid. I don't know. Anyway. Bon appetit. Thank you. I always love me some fried chicken.